All right, guys, so we're going to go ahead and just finish up these slides here on this little short YouTube video. So we left off here today in class. We just finished up talking about fat intake, so we're going to talk about carbohydrate intake here. And I've kind of already mentioned this stuff about the Atkins diet, or any kind of low-carb diet. What it does, it depletes glycogen reserves, which, as I mentioned in class, you lose a lot of water weight when you do this. It's really bad for exercise performance, as I mentioned. Because we know that low glycogen levels are highly correlated with overtraining as well as fatigue. So if you don't have glycogen, you fatigue very, very fast. Um, and so for very active people, the recommended amount of carbohydrate in the diet is 60% of your diet being from carbohydrates. Um, Pretty much almost all anaerobic metabolism uses muscle glycogen instead of blood glucose. And so if you don't have any of that, then you fatigue very easily. And so just like we have recommendations for protein being somewhere around 1 to 2 grams per kilogram of protein per day, for carbohydrates, it's about 10 grams of carbohydrates per kilogram per day, and this is just to stop protein wasting. So that's a good recommendation for that. And so we have a couple different methods and a couple different things we'll talk about as far as carbohydrate replacements and looking at how this affects glycogen storage. And so this is looking at taking in carbohydrates 2 hours or within a 2-hour window after exercise, or taking it in after 2 hours. And so this is looking at glycogen synthesis levels. And so the blue bars are when carbohydrate was administered immediately after exercise, and red bars are when carbohydrate was not administered until 2 hours after recovery. And so this is what we see, just much, much more glycogen replenishment if we take in carbohydrates right after exercise. And if we wait 2 hours or more, then we end up not having as much glycogen resynthesis. So just like with protein synthesis and muscle building, it's important to get the protein and carbohydrates in within that 2-hour window. It's the same thing with carbohydrates. If you want to build up your glycogen storage, you want to get those carbohydrates in within that 2-hour window immediately after exercise. And this is just showing how we deplete glycogen if we do continual bouts of long endurance exercise. These are 10-mile runs 3 days in a row. We deplete glycogen, and glycogen doesn't build back up. It starts where it stopped the day before, then it goes down even more. And this is even on a 40 to 60% carbohydrate diet. And so we're going to talk about glycogen loading here in a second. Another thing that's important though before we talk about glycogen loading is carbohydrate ingestion during exercise. And we see that there's a lot of research to show that taking in some carbohydrates during exercise, so like taking a swig of Gatorade or drinking some Gatorade or something like that during a long endurance event, is definitely helpful for getting your blood sugar back up, getting your warding off fatigue, getting your mental status back up, and so definitely very important during exercise if you're doing something very long. Also, what I've mentioned before, mixing carbohydrate and protein after a resistance training bout is the best bet for protein synthesis. And actually, chocolate milk has almost the perfect blend of sugar and protein. That's going to be a perfect blend to increase protein synthesis rates. And part of that need for carbohydrates for protein synthesis is the fact that when you take in carbohydrates, you build up insulin, you get an insulin release, and insulin is also an anabolic hormone. It helps you grow tissue. And we've talked about this before too, with carbohydrates and electrolytes being mixed. That's going to help us to absorb both sugar and the salt better because we use those glucose sodium co-transporters in the intestinal walls. So, and this is looking at a carbohydrate ingestion during exercise, and this is looking at blood glucose levels, showing that after long amounts of exercise, glucose levels decline. But if we go ahead and take a glucose drink, right at that point, it's going to make glucose levels go back up, and this is going to be very helpful for fatigue. Whereas if we just do a placebo drink, it doesn't do that, and fatigue happens earlier. So a few different methods here of true carbohydrate loading. So this isn't the same idea as just eating a big plate of pasta right before or the night before an endurance a bout or an endurance event. There's the main ways that are shown here And the main key to all of these types of glycogen loading is you actually start your glycogen loading regimen about a week before your event. Okay, so you start about a week before your event, and it starts with an exhaustive bout of exercise. So this means doing something for at least an hour, endurance-wise, and then actually going in and doing some sprints and doing some other things some high-intensity interval training, all in one bout of exercise, so you completely deplete your glycogen levels. So that's the first step, depleting glycogen. And now, these authors did it different ways. Some of them depleted glycogen and then ate a low carbohydrate diet for a few days afterwards. And then after those 3 days, they started building up with high carbohydrates for the next 3 days. And this was able to double the amount of muscle glycogen. That one was compared to this Sherman one, where they do reduced training intensity for a week. Start with the exhaustive bout and then the reduced training. And then the first 4 days during that reduced training, they do a 55% carbohydrate diet, and then the last 3 days they do a real high percent. And so then another method looked at an exhaustive bout of exercise, and then an 80% carbohydrate diet for 3 days immediately, and then the next 3 days leading up to the event, 60% carbohydrate diet with doing a little bit of exercise. And the bottom line is and so all of these different methods work. This is just showing that the Sherman and the A-strand method pretty much have the same effect and getting lots more muscle glycogen in. Okay, this is showing depleted glycogen states here, and then they both just skyrocket after that. Okay, and so that's a very good effect of this, and this is going to help with fatigue. And so the key that I want you to understand for glycogen loading is you need an exhaustive bout of exercise. That happens about a week before the event that you want to be ready for. And then you have to have at some point of a high carbohydrate diet, 60 to 80% carbohydrates, probably right after that exhaustive bout of exercise leading up to the event. And that's going to pack your muscles full of glycogen and get you ready for the event. Okay, and then a couple things just on this pre-exercise meal. There's a few different main goals we want to look at before a pre-exercise meal. So number one is to keep some blood sugar available. Okay, so what that means is we want to have an adequate amount of carbohydrates in the meal. Okay, and the timing is very important. So it takes about 3 to 4 hours to digest a carbohydrate-rich meal. So the idea is to have it about 3 to 4 hours before the event. You really want to avoid high fat and high protein intake due to slow digestion of those two macronutrients. And so the other goals are maintain hydration, so obviously getting some good amount of water in. Another interesting thing on goal number 3 there is to induce slight alkalosis. And so you can do this by having a single meal that's high in carbohydrates, because high in fat, high protein has actually been shown to decrease pre-exercise pH, which might make your buffering system a little bit taxed already to begin with. So if you start with carbohydrates, it's actually a little bit alkalinic, and this will actually increase pH and leads to better ability to buffer that lactic acid. So specifically, this is kind of a standard recommendation, about 3 to 5 grams per kilogram of carbohydrates, about 3 to 4 hours before exercise. Very low fat, also very low fiber. You don't want to eat a high fiber meal right before a bout, just because that can lead to some GI stress. And this is just kind of looking at an example meal. But that's pretty much it. So we'll wrap it up there, guys. We'll see you for the final.